I'm Atif Ali Khan. In this tutorial, I will talk about how to create FTS devices to perform fire modeling and how to make heat transfer files to perform heat transfer analysis in OpenCs and how to find the structural boundary conditions once your heat transfer is completed. So for this one, I create one module which is the name is device and elements, and you can download this code from my GitHub account. I give this link below this video, you can find, or you can find from my website. So let's start what we have done here. So I will suggest you that you can download this code as well, and first I will perform how to do these tasks, and later I will talk about that how to change in the source code. Actually, I will talk about what each task has been done using this source code so that you can make any change if you want in future based on your requirement and needs. So you can run in your any Python ideally you can use. So first, once you run, it will create this GUI which I make in tick enter package. So it has many frames like basic outputs, column inputs, beam, depends on the what structural materials, structure components you have, and OpenC's inputs, which I will explain one by one later, and I section entities, block entities. So there are some of the frames are there. So let's start how to do. First, you have to go directly where your data where you want to save your data, from where you want to extract files. So first, let's see. First, we need once you create a structure model in your OpenCs, so you create some nodes. Its nodes are in this format. Node number 1, which is its coordinate x, y, and z direction. So all three. So you have these all information once you get from OpenCs, and this is your beam column element. So you have a displacement column thermal, which has also a lot of input data. I think if you're doing OpenCs, you might know what is this. If you don't know, just go to this website, OpenCs for Fire. You can have all information there. So another one is for shell elements. So in shell elements, you also have an element number and the node number here. So some of information which we might need or don't need. So once you have this information, you can use this program. So first you have to go to the directory. So you go, I save this folder on my desktop, so I go there, tutorial, so I want to go device and elements. So once you choose this one, then after that, which quantity you want to measure as a input boundary condition for heat transfer analysis. So basically, if you go to on research papers, most of the time researchers are using adiabatic surface temperature, but you can use heat flux and heat transfer coefficients with heat flux and adiabatic surface temperature. So it's easier. So if you use one quantity, so your fire modeling will not take much time, especially when you are making a larger model. So here by default, I give adiabatic surface temperature. And first, what is your structure component, where you want to put your devices. So first I'll say in the column. So let's see what is, like for example, I have this floor of Plasco building. So it has various columns, trusses, and slabs. So these are trusses. So first I choose, okay, I want to take a data of columns, and then I choose units. So my structure component is in mm, so I choose mm. And then if I want to create entities, yes, of course I want to create entities. If you don't want, means you want to make only FTS devices, you can go for no, then nothing will happen here. And then entities, heat transfer in OpenC's heat transfer has different kind of entities like I section, block, and break. Again, you go to this website, OpenC's for Fire, so you can see they have different kind of entities: block, I section, composites, so 3D composites, and this one. So if you go through this website, here you have different, so these all will be added in future, different kind of entities, and maybe when people are developing these OpenCs, so more entities might be added, or same way it will be added here. That's why it's open source. If based on requirement, you can add it. So here you choose what kind of analysis you want to do, 2D or 3D. So at this moment I will choose 2D because I'm making for a large structure. I don't want to make computationally more. So let's go for only 2D, and once you choose 2D, you just add analysis. So it will create one file which add OpenC's heat transfer file. So, and let's put the basic inputs for OpenC's. So I choose a material. My column material is, I consider it's a steel material, and then I give the tag number 1. So I add material. So you say when I'm adding these things, if you go to the folder which is here, so I see that it created one OpenC's file, so it added this carbon steel here. So I want to, because my slabs is made by concrete, so I will use concrete, so I give the tag number separate, another tag number. And heat transfer constants, this HT constants are heat transfer constants, so it has a value like heat transfer coefficients, temperature, emissivity, and absorbivity. So you give this value by putting the space, and you can change it value difference, and then you give the tag number and add. I will suggest you for these analysis, if you have no idea how OpenC's heat transfer works, so you go to this website and you will know how this heat transfer files works. Phase change, if phase change is also, I will suggest you to go to this website to go that one. Phase change, if the material is changing out during heat transfer, when the heat is going inside, especially concrete, because moisture content if it's changing, so if there is a phase change there. The fire model type. For model type, for user defined model, this, for example, here's a fire model type for user defined, we take number 1 is a tag number, and I'm using adiabatic surface temperature as input, so you can change whatever the file name. It is a file input file name for a heat transfer analysis, so I just give AST because I'm using adiabatic surface temperature. And the phase is where heat flux is applied. For example, here's the I section here, so they have different phase 1, phase 5, phase 4, phase 9. So at which phase your heat flux is going to be applied, you have to explicitly mention when you're making this any entity. And model heat transfer constant tag means it is a tag number for the heat transfer constant. Like for example, for concrete you have a different emissivity, so you have to provide different heat transfer constant tag section. And the material tag, like for example here you give the material, like for as you have to give this one too. And like for example, if I give for concrete, I go 7, emissivity 7, then I give 2. So if you go to my tutorial file, it has created different ST constant 2 where 7, so it is, this data is getting added, appending for each actions. Now you have to show where you need data. You need output data at the phase. The output data you want, if you apply force, means for example fire is here, so you get data on this phase, so you just give phase 12, I need temperature data here. But you need sometimes temperature within inside the depth. So when you're taking data like this, you go, like for example in OpenC, the temperature data, you can, this all entities device is seen like this, so you can take temperature at different locations, T at this location and this location, so you can divide like 9, 25, many places. So basically, so here I give the option, so if you want to have multiple location within this depth you want to, you have to choose user define, and user define you have to choose how many points you want temperature data within this block or within this the depth of an entity. So I can choose 2, 5. So at this moment we give 2, 5, 9. So either you can choose 5, 2. So I choose first, like for example 5 is not coarse and not too fine. So for my simulation I will choose 5 for example. And then after choosing this one, so I will browse my notes file. So from here I will choose my notes file, which is for the structure elements, and then I will create the notes. It will create some dictionary. I will talk about it when I'm talking about the source code, what it's doing. Then I will take the elements file. This is my beam column element, then shell elements. So I create these files and shell elements. So this is again, this input you have to provide by default, like C1. So depends if you are choosing 2 points, so you will give 2 values like $sign C1. This is a variable for your sections. For example, here these sections which you're defining your section. So at if you are providing 5 locations, you have to give the 5 values at what location you are putting the temperature data. This is for structure when you are performing structure analysis. So it is required, so because you would be getting 5 different files. If you are showing the 5, you need at 5 points you need data, so it will be showing that 5 at 5. So you have to provide 5 values here, and same for shell. If you are for slabs, for whatever you are representing by shell elements, so you have to go like this. So once you are clear here, you created some data here. Now for example, for this this column at 0, 0, and height of this column is 3800, as I choose in mm. Increment is 1900. I want to put devices every 1900 meters, so I want to put in one column 2 devices at below and above. So it's below, it's my one entity size I'm thinking is 1900, so my device would be around half of this 950, and again 1900 plus 950. So I choose from, okay, my x is 0, y is 0, and my bottom of z is 0 here, and its height is 3800. And when you are creating FDS device, you have to provide the orientation of the device, in which direction so you have to go x, y, and z. So if I'm calculating temperature here, so my orientation would be outward, so +1. So I will choose here 1. And if you are choosing for negative direction, means below, so you have to give -1 if it would be in a minus direction, so -1. And similarly for 2 for y, -2 for -y, z for positive, -z for negative, -3, or 3 is for z direction. So this is 1, 2, 3, and -1, -2, -3. Clear? So once you put this data, and again you have to remember that entities, maybe structure you are using mm, but these all entities are in SI units, so all are in meter. So I put here my web width is 400 mm or 0.4 meter, 0.4 meter, flange thickness, and how much mesh is required for this one. I will suggest you again, you go there. So entity, how to do meshing within this entity. So you go there. So I provide this data here. So it will create this heat transfer files. So I provide this data, you have give whatever you want to give. So once you provide this data, you just put save. So what it would go, if you see there, it was creating me FDS devices. The quantity adiabatic surface temperature as 0.9 to 0.85. This is don't worry about it, FDS will run it and you can change it, or this will be changed. So IUR +1. So this is how your FDS device is created. And similarly, if you go to OpenSeas, it creates different I section entities. It creates the node set, that add, because I want 5 locations, so for each node set you can say for each entity it is creating 5 node set at d by 2 location minus g by 2 plus d by 2, because it's centroid at 0 0. Then it recorder means it will create 10 files for 2 entities for 1 column, because I give this comment also, so that when you are doing debugging or you have any problems in your program, in your results, so you can see where is the problem. So this is comment I just gave so that you can know which column is with what. So this is how you done. And then this is element set. This is also, it is creating that at 28 elements, element number 28, element number 29, within this range there are these elements number. So and each element, the output data we get from heat transfer analysis, that file name is temp1, means temperature 1, temperature 1. So within these elements you will use these temperature data, and within these elements you will use the device data of FDS of the second device for these. So like this one, it will be creating for everything. So this is for example of column. So column is basically difficult because you have to give one by one for columns, because you actually don't know for each geometry how far each column is. Some column is location, they are not equally distance. So this code at this moment is give individual columns, but you can change it if you, in your geometry all columns are equal distance, so you can make some changes. So now let's go. I want to create trusses. So what I want to do, I want to do, this is within this 5 meter, whatever this truss is here, I want to use one temperature data here and here one temperature data. So accordingly what I will go like, because I choose, and for this trusses also I'm suggesting by I section. So now I will go here truss. So my direction of this, my trusses is in this direction. I want to take in this direction, in Y direction here. So I will choose here Y. So initial value of my X is 0, Y is 0, and my truss below height is 3400 and height is 3800. So I put here 3400 and 3800, and I want every 5 meter or every 2 meter, depends on how close you want to put your FTS devices. It depends on this, depends on the user, or depends on your accuracy. So for example, for this tutorial I check like 5 meter. So 5 meter in this direction increment, which each increment in X direction. So every 5 meter I will put one device, and same for Y, I want to give the same for Y. So for each square of 5 meter I will get one FTS devices. So my length in X direction, for example here in this case I have like 29,400. For example here I give like, for example, 30,000, and Y direction is also 30,000. And as I say, orientation of FDS devices, at is in the Z direction, so my FDS device would be in inverted direction. The temperature is taking in the below, so I will give -3. If it will going up, so it will be +3. So here -3. So again, I think my I section is the same size I'm using, or maybe my section is little thicker, or my web is thicker. So I take like, I change the mesh size of this, I change these values, and then I save it. So if you go there, you can see my FDS devices. So many FDS devices created. Like for example here, I created for slab. So 36 devices for slab is added in this direction, that direction. So 36 FDS devices are created. So similarly you have how much OpenCs. For OpenCs also similar number of entities are 38 entities now. There's 38 devices, so each device for each entity there's this one. So you have for each entity you have 5 node sets, so you have 190 node sets are created for Trusses. And same when I see that, so this is it's providing which elements at which temperature data would be come from after node set creation. Okay, I guess from here it's clear now. And now I want to say I have slab as well, so I go for slabs and I choose for here block entity. Okay, and I will change the material. My material for slab is 2, material tag is 2, so because I'm choosing concrete here, material tag is 2, and heat transfer constant is also tag number is 2. So once I will change this value, I will go for the slabs. Again I choose the same direction, Y direction, increment 0, and my Z is 3800. Initial 0, length along the slab I will change again 30,000, same as there, increment 5,000, and width of the slab in Y direction it is 40,000. And let me check. Okay, block. So here I will put, because I'm choosing is a block here, so I will go value, I will choose this value, mesh centroid again 0 0. So width of the block I'm taking 0.4 and width of depth of the block at 0.4, and mesh along this direction. You can say again, you can go and check here how do this meshing has been done here on this element level. So again you go there and you create like this, and you can see FDS devices are created here. So each equal distance you have FDS devices here, and OpenFire file is created here. So you have as much as, let's see how many, so I have like 74 entities, and you can say I have 74. So this temp like AST1 is, so basically this is how my temperature data will come. And now this element set 2, so you can see this is so many, all elements know which temperature data I will get after doing heat transfer analysis. So 74 after structure analysis, heat transfer analysis, this temperature file will be created, so it knows which temperature data I need to put there. So once you have completed all these tasks, you just give how much temperature simulation time is. Like my simulation, fire simulation, I like for 20,000, and my steps, I take my steps like each step I take like 5 seconds. You add this one, so you can go there and you check your this heat transfer, you save here, and your analysis data is added here. So heat transfer is like 12,000, so it will divide it by 1205, and you can take heat transfer. So your heat transfer analysis, heat transfer data file is ready, FDS file is ready, FDS devices are ready, but you have to put like file load and other information you can download. You have to create and just copy paste this data there, and similarly your element task is here. So this is element, so you know which temperature they are. So this way you can create all this important data is mapping, that how the data will map. This program is wonderfully can do all these jobs here. So now this is how it is done. Now let's see how the source code is there, is what it is doing, how you can change here. So first of all, this is the important libraries which are required for this one. Tick enter is to make the GUI, and this is for scrollers, so nothing to do with this one. So first I will the create folder. It will create some temporary folder if you want to create any folder here, and there are different files which are required. So location, this part of the code, or this function helps you to go which directory you want. So it's just to get the directory. So os dot change directory, it just change the directory. So here you choose, you can add what are the structural components you want to add. So if you want to add some other components like transverse beam, you can create here, you can add. So it will create this one. I don't want to add here. So you want to choose unit, meter. If you want to choose imperial unit in future, you can add here. So what are the entity type? At this moment I put I section, block, break. If you want to add composite, so you can add like this. So here you can add all this data, and then add analysis, means 2D, 3D, or 1D, whatever you want. You can add here also analysis type like 2D analysis, 3D analysis. So once you choose, it will save the data in this OpenFire file. So here material type, at this moment you see you have 2 materials. You can add how many materials which are available in OpenFire. So go to the OpenFire manual, so you can get this data. Also whether you can add any material or not. So here you add material from this function, and here you add heat transfer constants. So you can provide the heat transfer constant values here. This is by default, I put it here, so you can change it here anywhere you want. So here are the inputs for important, like what are the input which you are putting the entry box. So here the entry box here. So you have the file model type 1 or 2, phase change, input boundary. So whatever the requirement, you make the one entry box here and make the location on your frame. Here location depth means how many location you want. Temperature, like I want temperature at 2, 5, 9. You can add more if you want this one, but you have to change below in the code. So these are the inputs for the columns. X direction, Y direction, Z column height. So these are information here, orientation. So these are the inputs for the entry boxes for different area. So once this is all inputs for different, for slabs, for OpenFires, like for I section entities, centroid of X, centroid of Y. So you can get this information very easily there. So now let's check the define, which is actually def. If you don't know about Python, that is the methods which is known. So first, this is Fts FileMaker, how to make files. So I want to make columns. So this, it will create, if you choose column, it will go there and it will create the devices for this one. So I have few functions here. So you can go through this function. This is to create Fts file. So it will create in the same format here, which is required by FDS. FDS written in Fortran. So you can go there and you can add, just copy paste of these devices, which is created based on the location in the structural components. So here different kinds. If you have a truss for different values, different structure components, I put the values. Now this is a function for entities. Like if I have an I entity, I provide the I entity for I section, the mesh detail, and node set faces at which which face you have node, like if it's on the if at the face, because I have node set, I want to create that face, or I want to set for the location. For here I choose like either 2, 5 or 259. So you can choose whichever you want, 259. So this function can take when you choose locations are user defined, so it will give you this. So once this part of the code, create the file models, which are your model type. So these are different part are providing for the OpenFire files. If many functions for the recorders, for the mesh, For like if you have an entity is a block entity, so this is different way because the definition of entity would be different. So this part of the code does that. Mesh block means for the block mesh, and these are the entry for the element sets. This will provide you, like if you have a 2, you can give 2 values, because the section detail you have to provide for the structure file, which is was here, this section type. So you provide each element 28, this is the section detail you have to provide. So this part of the code does that one. Then open source nodes file, where I browse the nodes file, which you see I was browsing. So here shell elements file I browse here. Then then I create the nodes dictionary, which create the dictionary of the nodes. Dictionary is a data type in Python, if you don't know about the Python. So dictionary is a data type, like integers, tuples, floats, double. So this is one kind of data type, is called dictionary. So I create the dictionary of the nodes from this function, and it will create the dictionary with the key. Dictionary has a one key and values. So first element, which is element size, is like first element has this xy, node number 1 is xyz, so it will create which nodes is there. So this dictionary create. So similarly for beam column elements also, it create one dictionary for each column. Each element has different nodes, so it will tell you which nodes is there. So it creates the nodes dictionary. So, and this within this area, within this range x, y, z, it will find out how many elements are there, or which based on the nodes and element there. So these are the function. This is a function which found that within this how much elements for the key values, because I need a key, means I need what the element within this range is there. So x, if x, y, and z, and so all these 3 values should match, then it will give you the key value of that dictionary. So this is how it found. So this is the main output function which you are save. When you save, this is the output data. So here you provide, whenever you provide this value, it gives you all data here. So these are different kind of, these are the codes which functions I'm using here once I'm saving data. So this is creating for elements files. So this is the functions for the creating dictionaries, which I discussed earlier. So here you provide all these functions, and it is creating these files. So this is creating all these files. So here basically, which I wanted to tell you about these functions, which function is doing what. And once you can output data, this is like for save file, which is output data comes. So here it giving me the output data, this function, which is basically giving me all this detail whenever I change any entry value, and when I save, it give me all this data, which all this function analysis. Once you are done this one, you can, because I was adding that how much temperature, initial temperature I need, how much simulation time it is. By default I'm giving like 200, so I can give like 1200, whatever. And for each time interval I give like 5, I don't want to give more. So this is time step, and then you just save the file. So this element code is, at this moment you might not require, but if sometimes it happens when your truss and column at the same location, so maybe the same node is included in truss elements as well as in columns. So this part of the code find the duplicates, and it removes the duplicates. So if you are, so that's why there is, so if you have a duplicate, you have a chances of duplicate, you can just update the element file. It will remove the duplicate from trusses or beams, and it will put only in the columns. So, and because we have no issues with the slabs, because slab is usually by shell elements, so there would be no issue. Even if there is issue, you can use the same code, you can modify this code, and you can remove the duplicates if you have any chance of duplicate. Usually you do not, but if the truss and beam are passing from the same location, you might have, but you can remove it through this one. I think that's all for this for this module. We will talking about for other modules in other videos. Thank you very much for listening. I hope it will be helpful. If you have any questions, you can just email us, any of the part of the team, and basically this code by me. So if you have any question related to this code, you can contact through GitHub by creating issues, or you can just email me. Thank you very much.